So hello guys and welcome back to my YouTube channel. In today's video we'll be looking at LangGraph. So LangGraph is one of the frameworks we use for AI agent orchestration. So one of the advantages of using LangGraph is that it gives developers low-level control over certain things. You'll be in control over a lot of things, which in most other orchestration frameworks it's not like that. All right, so we will in this video I will try as much as possible to demystify LangGraph, look at the basic building blocks, look at the basic things that you need to understand about LangGraph in the best way that I can, so that you can understand how LangGraph works. All right, so there are some basic pillars of LangGraph, which are it can give you persistence. It has persistence because it has the memory, which is when you talk about the memory, talk about the long-term and short-term memory, which are the LangGraph checkpointer for short-term memory and LangGraph store for long-term memory. It has streaming, whereby you can be streaming your response. It has human in the loop, and it has controllability, which is one of the sweetest. You control how you want your agent to behave in the exact way you want it. All right, so um to build an agent in LangGraph, you need to understand four things. You need to understand the state, node, edge, and the graph. All right, so these are the four things you need to understand. I will be picking them one after the other. All right, so um, let's see how you understand all these things. So, what is the state? All right, so the state, just like the name implies, it's just a state in which your agent is at a particular time. So the state is always a schema. All right, so what is a schema? A schema is a data structure that you can actually use to store all the data that your agent is making use of at that particular time, or maybe some input that has gotten from a particular another agent that can form the output is got from a particular agent that can form an input to another agent. Just understand it as a schema that of a data structure of all the data that your agent needs to work at that particular time. That is just the state. All right, so this is the state. The state is always a typed dict. Okay, so defining it as a typed dict will enable you to access the instance of this class as a dictionary. All right, so defining a state here, and it has one member variable, which is the graph state, and I'm defining it as a string. All right, so if I define an instance of this class, it will have one member variable, graph state, and if I want to access it, I will be accessing it like a dictionary. All right, so this is just the state. Now this is just a simple state. I can have more data here as member variables. All right, so it's just a data structure that is holding a data of all the things that your agent needs at a particular time, or all the data it is working with. Some might be initialized, some might not be initialized. What you just need is that this is just the data that is flowing through your agent, so that at every point in time the agent can pick to maybe work with a particular data. So that is just the state. All right, now what is the node? So nodes are like functions. Okay, so this is a simple node that I defined here. So nodes are like functions. All right, so what does these functions do? So these functions, their work is they will be executed at each point in time. All right, so a node is just like a task that you want to execute at a particular time. So you define that task as a function. So anytime that node is executing, that function will be executing. So this is just defining a function here that anytime we call this node, that will call node here, this function will be executed. All right. So I'm going to comment out these two lines here because I want to show us something comment out these two lines, and then I'm going to run this, and I'm going to run this. All right, good. So this is just how a node is. Now, what are we doing in this node? Okay, so in this node now, um, remember in each node, you need to, when the agent is running, it always passes the state of that agent to every node. So you must collect the state. So you need to pick the state. So this is the state of the agent as it will be running. So it is a type of this state, and we know that it has only one member variable. So the graph state is equals to state of graph state. So we are trying to pick this graph state. Whatever that is here is what we want to pick here. All right, which is a string. Okay, so you will see later how we can actually manipulate them. So this is just a simple node. This is just one node. Now let's look at how you can build a graph. Now, to build a graph, we need to import few libraries. So from LangGraph.graph, we need to import the start, the end, and the state graph. So the state graph is the instance that we use to build the graph. All right. Now, so we're going to first of all get the instance of the state graph, which is we'll call it builder. Builder is equals to state graph, and we are passing the graph state. Understand this, anytime you are initializing the instance of the state graph which you're going to use to build your graph, all right, you need to do what? Pass the schema, which is the state that you want your graph to be in. All right, so remember that we have looked at the state, we've looked at the node, then we want to build graph. So how do you build a graph? You build a graph using the nodes that you have. I'm building this node. We'll be adding this node just like an edge to our graph. We're going to see how it is done. All right, so let's follow gradually. All right, so first of all, you need to create an instance of the state graph, and then you pass the graph state. You pass the schema you want to use as the graph state. And which schema are we trying to use as our graph state? This is the schema here. So we pass it. And then first of all, you need to add all the nodes that you want to make use of. So we are only working with one node, so we add only one node. So this is the function, and we are calling it node. So anytime we call this name, it will be referring to this node. All right, that's good. So we are just adding just one node. And then this is we now building the graph itself. Okay, so to build the graph, we add edge by edge. So first of all, we start from the start edge, we'll add the start. So we want our graph to go from start to the node, that is this function, and from this function, it should end. Just as simple as that. So we add them as edge. And after that, we are going to compile the graph. So let me run this, and it's going to run. Good, we've built our graph. So now I'm going to display this graph so that we can see it. So to display the graph, let's see how it looks like. So we are using the ipython.display to display the graph. So I'm going to run this. Okay, so this is the graph. Okay, so this is the graph. Now this is what we're able to build here. So we started from the start, which is this particular node here, to this node, to this node. So from the start, you see we added an edge. We are going from start to node. And we added another edge going from node to end. All right, so we went from start to node and from node to end. So this is our graph. All right, so for you to start running this code, there are a couple of libraries you need to install, which are listed here. Okay, so these are different libraries you need to install. You need to install LangGraph, LangChain. Okay, LangChain and LangChain OpenAI is for the AI LLM invocation, and then python.env in case you want to use the environment variable. But basically, what we are working with for now is the LangGraph. So ensure that you install this LangGraph. Okay, good. So this is our graph. Now let's look at how this graph is being invoked. Okay, let's look at how this graph is being invoked. So to invoke our graph, you're going to say graph.invoke. So graph.invoke is what you're going to use to invoke the graph so that the process or whatever we defined in this graph can run, and we're going to see how it is running and the output it is producing. All right, so it takes some arguments. We're going to pass an input. An input is the input we need to pass that the graph will work with, and the input is always a dictionary. Now the input is always a dictionary because our schema is a dictionary. So what happens there is when you pass this input is being used to create an instance of this schema at the graph, and then that is what is now passed to each of the nodes while running. So that is what we'll have here. So one of the member variable here is graph state. So and it is we are going to be populating this graph state. So that's why we have graph state, and we are passing this is the graph state. Okay, so that is why we are passing this. So remember, look at our node. So when this node runs, we have a print statement inside this node. So we are going to run this line of code here, and you see that we have a code printed here. This is the node. So meaning that this function actually ran and it printed this. Okay. So this is to show that once this man runs, it passes this schema to the graph, which will pass to that particular node when the node is running. And once it calls the node, whatever we have inside the node will be executed. So what we have inside this node here is this is the node. That is why it's executed. Now I can adjust my node. Okay, so let me add this other print statement. All right, so I want to print the state of the graph, which is what I've passed in this graph state. So I said the graph state is. So what I'm printing here is the exact data it was fetching from this member variable when it was accessing it here. So I'm going to run this code, and then I'm going to rebuild my graph. So my graph has rebuilt, and I'm going to invoke it again. So you see that this line was printed, and then this other line was printed. The graph state is, this is the graph state. Now this is the graph state is what we passed here. So you see that it was able to read the state of the graph, because what happens here is once you invoke this graph that you've built here, the first thing it does is to take the input and create an instance of the schema, and that schema is the state. Remember, the state is the data that your agent is supposed to be working with. So it must be initialized, and it will be passed from node to node, from node to node. So if I have 10 nodes here, at the invocation of each node, it is going to pass the state to them. So anytime I update the content of the state, then I can access it throughout other nodes. So this state is just the schema that the agent will be working with throughout the life cycle of the agent until its execution is done. So that is why the state is very important. And building a stable state schema is also good for your agent so that your agent can actually work perfectly. Now, how do you update the data in the state schema while your agent is running? So the only way you can do that is by having a return function in your node. So, and what you'll be returning should be a dictionary. So once you return a dictionary, now this is what happens. So I'm returning a dictionary and I want to write to this member variable, which is the graph state. Remember, that is the member variable we have here. And I want to update it with this is an update. So what happens here is, once I return this, under the hood, the graph is going to update this member variable in this state schema with whatever value that I passed here. That is how it works. So this is the only way you can update the data in your state schema while the agent is running, by adding it in a return function. So how this happens is, at the beginning of the node, you pick the current state, you work with them. If you have some result that you need to update to the state so that the next node or the next agent can work with it, you have to do it at the return function. So at the return, so you have to do it here, and then it will update your state schema for the next node or the next agent. So this is basically how it works. So I'm adding this now. Okay, I'm going to run this and also build the graph again, and I'm going to invoke here. Now, what I'm having at the output here didn't change, because at this node I only have two print statements that are printing this and printing this. So how do I know that this state was actually updated? That brings us to this result. So anytime you invoke your agent, it returns the current state of that agent. So this is the current state of the graph, this result. So if I print this result, it's going to be showing me the current state of the of my graph. So this is the current state. The graph state is having this is an update. So this is basically how LangGraph passes data. When it's done executing one node, you can update the state so that another node will get the current state and then use this to process whatever it will process. So this is one of the sweet aspect of LangGraph. There are a lot of things you can manipulate by yourself. All right, so let's look at something that is a bit complex. So here now, I'm defining three nodes. Okay, node 1, node 2, and node 3. And these three nodes have different functions, what they do. Now, let's look at these three nodes. Remember, each node is taking the current state. Each node is taking the current state, okay? All right, so, and the graph state is just reading the graph state. Remember, we are still working with the same schema, which is this state, which have only the graph state as a member variable. Okay, so I'm picking it to have the actual data in the state. So, and I'm having a print statement here to indicate the node that is being executing. So when any node executes, I'm going to get this print statement. Node 1, when it's node 2, I'll get node 2, when it's node 3, I'll get node 3. Okay, and then I am updating the state schema at the end of each node. Now, what am I doing here? I am taking whatever we have in the state and I'm updating a particular string. I'm concatenating a particular string to it. So here, I am saying I am. Here, I am adding sad. Here, I am adding happy. All right, so this is just the different nodes. We're going to see how these nodes will be executed. Now, I have another function here, which is another node, but this is a conditional node. So this is just like a tweak. Now, the reason why I'm adding this is for you to understand that you can actually make decisions while your agent is running. So conditional node is basically used to make decisions while your agent is running. So the decision is which node should be executed next, which agent should be executed next. So you use the conditional node to decide it. So this is what you use to give your agent intelligence on how it should operate. maybe from the output of a particular node that was executed, which node should execute next, or should it just go to the next one? All right, so I'm calling it decide, and I want it to return um, a static output, whether node 2 or node 3. All right, so what happens here is we generate a random number. Okay, so yeah, so I'm printing the random number here. So we see the random number we generated. So it's generating a random number between 0 to 1. Okay, so if the random number is greater than 0.5, I want it to return node 2. So that means I want it to return node 2. If it is less than 0.5, it should return node 3. So this is just like a decision that will decide the node that will be executed. So if the random number generated is greater than 0.5, then node 2 should be executed. If it is less than 0.5, node 3 should be executed. So that is just basically what this decision node is doing. So now let's look at how the graph is being built. So remember I have 3 main nodes here. So I'm going to add them as nodes, passing the functions and then naming them node 1, node 2, node 3. Now note, if I'm naming this node 2 here, and I want this decision node or conditional node to return the exact name of the node to be executed, I will make sure it matches what I have here. That is why I have node 2 and node 3 here, and it matches node 2 and node 3 here. So how do I want this agent to work now? So from start, it should go to the node 1. So that means from start, node 1 should execute. Then from node 1, I am adding a conditional edge, which is decide. You see, I'm going from node 1 to this function now. So this function will return 2 names. It's either it returns node 2. So if it returns node 2, node 2 will start executing. If it returns node 3, node 3 will start executing. Alright, so I am now adding another edge. If node 2 was returned, it should go from node 2 to end. If node 3 was returned, it should go from node 3 to end. Now, this is where I can add more logic. So I can actually tell it to even go from node 2 to node 1 and start the whole process afresh if node 2 was executed. If I pass node 1 here, that means it's going to go from node 2 to node 1. So this is me now controlling how execution is being done. You see, it is now becoming smart and becoming intelligent. All right. So I'm going to run this code now. All right, so look at how the graph looks like now. Okay, so from start, we are coming to node 1. Then this dotted line here means that there is a conditional edge here because it is not going from here directly. It means that for it to come here, there is a condition. Okay, but from here, it is going to end directly. From here, it is going to end directly. From start, it's going to node 1 directly. Now, let's now look at our nodes again. You see that at node 1, I am passing I am to whatever the graph or the state has already. And if node 2 is executing, I'm adding sad. If node 3 is executing, I'm adding happy. So let me execute this now. Let me invoke the graph, and we're going to understand what we'll have there. So I'm going to invoke the graph. So remember, we are going to pass in the input, which is a dictionary that will be used to initialize the state of the graph. Our state schema has this graph state. Okay, that is why we are passing this data to the graph state. Okay, now let's invoke. All right, now let's look at what we have here. So we invoked we see we have node 1 and node 2. That means our node 1 executed and it went to the conditional edge and is generated 0.5. And look at here, we say once it is greater than 0.5, then node 2 should execute. And look at what we have, 0.52. That means it's greater than 0.5. Node 2 was executed. Now let's now look at the state schema when all these things are done. Remember that what was passed here was hi Felix. And what we have here now is hi Felix, I am sad. Okay? Hi Felix, I am sad. Okay, now let's go back to our nodes. We passed hi Felix. And if node 1 is executing, it should add I am. All right, so which is what we have here. And if node 2 executed, it should add sad. But if node 3 executed, what we would have gotten is I am happy. So now let's run this again and see if node 3 will execute. Okay, still getting number greater than 0.5. Still getting number greater than 0.5. Wow, it wouldn't get something lower. All right, so let's keep executing. Okay, now we got something lower. All right, we got 0.4, and you see node 3 got to execute, and what we have here is I am happy. All right, so this is just how your graph can actually work autonomously on its own, just by the logics that you pass in your conditional edge, and then be able to pass different data from one node to the another node, from another node to the another node. So um, in this video, we didn't look at LLM invocation or try to integrate LLM yet. We're only trying to understand how LangGraph works and how you can build a graph with LangGraph. All right, so if you understand this structure now, that means you can add any logic in each of these nodes, and they will be able to execute. Now let's have a rundown of what we are looking at. So remember, what we are trying to understand here is the state, the node, the edge, and the graph, which is the basic building blocks. All right, so we understand the state, that the state is the schema, which is the data structure that your agent is working with or your graph is working with. Okay, now the nodes are the different functions you need your graph to be executing at every point in time. Now edge are adding the nodes to the graph, and then the graph is the full structure of your agent, how it should work. That is just the graph. So what we built here is the graph, and what we have here is the graph. Okay, and this is the graph flow. You see how the graph will flow. All right, and once it is executing, it will actually flow like that. So this is just the fundamental of LangGraph, and if you understand this, you can build any project with LangGraph. All right, so if you like the video, give us a thumbs up, subscribe to the YouTube channel. We'll have a tons of video coming for you in building AI system, AI agents, AI multi-agents. Thank you very much for watching the video. Meanwhile, keep coding and keep practicing. See you in the next video.